Remember, no school tomorrow or Friday. So this is the last day of the week for you. And then we have next week and then spring break. I'm counting down. You know how many seconds there are? The week of the 11th. So 11th to the 19th. All right. We're gonna finish up chapter 3 today. It's the last thing. First off, we talked about addition. Then we talked about multiplication. Then we went back and did subtraction. Now we're doing division. What is division? How do we do division? What is division? Think of back when you were in elementary school. How did the teachers introduce division to you? Exactly. Yeah. How many ways can we divvy up or separate or divide this pie or this pizza or these donuts into how many people we have? Which is one of the methods we're going to talk about. Division is finding the number of ways a value separated into smaller groups equally. Division is a process of finding the number of ways you can divide something or separate it into smaller groups. One of the first examples you see in school is either a pie or a pizza. And you figure, okay, we have 2, 4, 6 people in this room, 6 students in this room. How do we cut it up? That's what the whole thing's about. How do we cut it up? How would you cut this up if you had to cut up into 6 equal slices? How would you do it mathematically? And how would you do it if you're at a football party and you were going to cut a pizza up, give it to everybody?
How would you fit in that? And then put it in the other way.
Okay, but now we're in trouble because we have 4 pieces and there's 6 people. We can't cut these in half because then they won't be equal sizes. So what do we do now if we do it this way? You could keep on dividing, keep on cutting these up. Do we have enough now? Well, we have 2, 3, 4, 5. We have 2 extra pieces. We're still back to the problem that we had originally. How do we cut these 2 up so everybody has equally the same amount? So how would you do that using this way? Remember, you're at a party, you're the host, you want to give everybody equal size pizza. What would you do? then we'll be back in that problem again, because now we're looking at dividing in half. If we cut these two in half, we still don't have enough pieces. And let's say if we cut these two in half also. And these, what happens now? How many pieces do we have now? Yeah, but we had 8 originally. We cut those in half, so we have 16 now. Does 6 go into 16? No. So what if we cut it again? So now what you're so if we do it this way, then we have to look at how many ways can 16 fit into these or 6 fit into these. So what are the multiples of 6? There's 6 times 1, 6 times 2, 6 times 3, 6 times 4, 5. And we keep on going until, if we do it this way, until we have that many number of pieces. Because we have 16 pieces now. Is 16 in there? No. If we cut it again, we double that, we get 32. Is that in there? No. If we cut that, we get 64. Does 6 go into 64? You'll be slicing that pizza forever. So maybe cutting it in half the first time wasn't the best idea. Although that's what everybody was, I'm going to do. Let's think of another way.
Like a Y shape, so it's 3 slices.
That would be more because,
Then
but now what's difficult about that? Making sure each of these angles are the same. How much should these angles be? What's a total circle? How many angles in a circle? How many degrees in a circle? If you divide that by 6, what do you get? How many times is 6 going to 360 or 336? Each angle would have to be 60 degrees. How would you figure that out? By this time, the pizza's getting cold. If you had a compass and a ruler, that'd be easy. Find the center of the pizza first, which is another whole problem in itself. Finding the center of a circle. And once you find that, just draw a radius to the outside. And from that, use your compass and mark out 60 degrees. And then again, from there, mark out 60 degrees. Okay, so that's only 3 pieces. What do we do now?
but we split each 60.
Yep, cut those in half. Now we have our 6 pieces. It's not as cold as that one, but yeah, so the problem with division, it gets to be complex sometimes. Because the last thing you want is too much leftovers or not enough to go equally to everybody. But yeah, pizzas are the biggest problem because they're round. Which is why in Europe, they don't have round pizzas really. They have rectangular pizzas. In Italy, you go to a pizzeria, it's mostly the tourist places will have round pizzas because that's what you're expecting to see. But no, it's much easier to make it into rectangles. Now it's much easier to find out how many spaces you need. Okay, so let's look at the three methods we're going to look at this morning. Or the models. Or for division. The first one we're going to look at is called repeated subtraction model. Repeated subtraction. Remember what I said last class, that addition matched with multiplication, because multiplication is multiple additions. Now subtraction matches with division, because what we're doing here, when we're dividing something, we're taking one set and subtracting bits and pieces of it out equally. The second model is the set or partition model. The third most common set is the method is the missing factor model. So let's look at the first one, repeated subtraction. Remember, subtraction goes with division because what's division is breaking up into smaller pieces. And that's what you're doing. You have a whole set and you take away pieces, and that's the subtraction part. So let's look at repeated subtraction. Yes, they work great. They work great if we have M&Ms or stuff like that, or cookies or anything tangible. We could do the same thing with a pizza, which is the path we were taking earlier. Remember, if we had our pizza, we cut it in half, cut that in half, cut those in half. As long as you have at least 6, you're good to go. Well, instead of 6, let's look at 3. That way I don't have to do any boxes. So you have 3 people. That you're going to give the pizza to. You're going to share the pizza with. So you start. You take first piece, that goes to person A. The second piece goes to person B. Third piece goes to person C. Those are gone. And we repeat the process. Take away that piece, take away that piece. Now we have these 2 pieces. And as we said earlier, we can, if we can cut those in thirds, it's great, but again, that's much more difficult. So we'd cut these in half. So person A gets one, person B gets another one, person C gets one. Now we're down to only 1 piece. You see the problem with this? How big are those pieces going to be? So that's one method. Let's say we had 24, 10, 11, 12, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. We have 24 cookies or Skittles for your class. And you have 8 students. How would the students figure out how many each person gets. The way the kids would do it would be you have 8 students. 1, 2, 3, 4, 5, 6, 7, 8. If they were fair students, they would start putting 1 to each student and then keep on going that way. That's one way of doing it. How can we use subtraction method? Well, we have 24 Skittles. If we give away 1 to each student, we give away 8. How many do we have left? 16. Again, we still have more, so we give away 8 more. 16 minus 8 is, and we give away 8 more, so we get 0. All you have to do now is count the number of times you gave away 8, and that's the number. 24 divided by 8 equals 1, 2, 3. How can we prove that that's true? That's a good answer. How would you test it? How would you prove it? Well, what's opposite of division? Yeah, I would take 8 times 3 and see if it equals 24. Because division is the inverse of multiplication. So if I'm doing 24 divided by 8, I get 3. That means if I do 8 times 3, I should get 24. Remember this thing? We did something like that with the addition subtraction part. We had 15, 8, and 7. What this thing means is this. If I go from big to small, I'm doing division. So 24 divided by 8 equals 3. 24 divided by 3 equals 8. But if I go from small to big, 8 times 3 equals 24. Or 3 times 8 equals 24. So again, that's what you'd use to help your kids practice their multiplication division skills or addition subtraction skills and to test to see if their answers are correct. So is that true? Well, we'll try it out. 5 times 3 equals 15. Does that equal 27? No. This is one thing that a lot of teachers don't stress when it comes to mathematics. What does CYA mean? Check your answer. Always check your answer. I can tell you right now, I bet you almost none of you will do that. Once you get an answer, you just plug it in there and see what the computer tells you. Because if you think about it, if you check your answer, should you ever make anything less than 100 on homeworks or tests? No, because it's right there. You would know before the computer tells you if it's right or wrong. So think of it that way. There's no reason why you should ever make anything less than 100 if you check your answers. But again, we're just happy to finish with the test, get out of there. So again, stress that when you start teaching and start putting into practice yourself. Always, always, always check your answer. Okay, so this is how subtraction works. You have a total number, and we see if this number fits in there. How many times can we subtract it? As long as this number is bigger than what we're subtracting, we're doing good. And the first part I showed you with the Skittles and things, when you put them in different ones, that's what we call the partition or the sets. So we started off with, let's say we had 12 Skittles. And we have 4 students. How many Skittles does each student get? Well, and here's a subtraction method. 12 minus 4 is 8's still bigger than 4, so I'll keep on going. 8 minus 4 and 4 minus 4. If we get a 0 here, we're doing good. Why? What's that? It was, what is this number called? What's that? Very good. Exactly. If you get a remainder of 0, that means it fits in there perfectly. So how many candies does each student get? Yeah, we have 1, 2, 3. So we could take these there are 4 people, so I take 4 candies. I put them in each student's bag. I take 4 more candies, put them in each student's bag. And then I take 4 more candies. First example here. Now, elementary school teachers do this all the time. For those of you who go into elementary school teaching, you have to remember that it's a labor of love. You're going to spend more money during the year getting stuff for your students, but you do it because of love and you love what you're doing. And it's fun watching the kids play with the stuff. Candies or cards and stuff. Let's say you had 16 students. It's Valentine's Day celebration. Each box has 18 cards in it. You can either buy that and have leftover cards, which you're going to eventually throw away because they'll just pack up. You won't have the same one next year. Or how many of these cards boxes can you get to make it so each student has the same number of cards and there's no leftovers? How would you do that?
You find multiples of 18 and 16, and then figure out which one.
You find multiples of 18, yeah. And how would you find that? Yes, you could do that. Or what he's saying there is start with 16, start with 18, and multiplies 16 times 1, 16 times 2, 16 times 3, 18 times 1, 18 times 2, 18 times 3. No, 4. And keep on going until the numbers, you find two numbers the same. That's one way of doing it. What's the other way? Do 16 and 18 have anything in common? Yeah, so they both have a 2 in common. 16 divided by 2 is what? In other words, what's half of 16? What's half of 18? Now we just have to look at 8 and 9, which is a lot easier than those. Do they have anything else in common? 8 is made up of 2 times 2 times 2. 9 is made up of 3 times 3. So there's nothing in common. So what's the smallest number that both of these fit into? What's the smallest number that they both fit into? 8 doesn't fit into 9. Use your pencil and paper, figure it out. I'll save you some time. Because this one's made up of all 2s, this made all 3s, it's easier if you just multiply each other. 72 is the smallest number they both fit into. So how many boxes of 18 do we have to buy to get 72? You think it's 8? Because 8 times 10 is 80. That's a little bit too big, yeah. The subtraction method would be best over here. 72 minus 18 is what? So that's 6. Minus 18. Minus 18. Minus 18. So we have 1, 2, 3, 4. I'd have to buy 4 boxes so I won't have any leftovers. And then how many cards would each kid get then? There's 16 students, right? There's 16 students and each box has 18. Yeah, 72 minus 16. 72 minus 16 is 56. Minus 16. What? 6. 40. Minus 16. Oh, 2. 56. 40. Four times 18. 72. All right, what did I mess up? This one should come out to be 0 also. Just rip the cards in half, give it to the kids. Let me think about that one. There's something, this should work out that way because we know that both 16 and 18 should fit in the 72. Because they both have a factor of 2. So 18 times 4. Sixteen times. Whoops. I don't know what I did wrong there. But it should work out because it's multiples. I'll figure this out. I'll send you a remind message over the break, over the weekend. But that's the partition model. I forgot what I did wrong there. All right, and the third one is missing factor. It's what we've been doing already. What do we mean by missing factor? What is a factor? Or if I gave you the number 9, what are the factors of 9? 9 breaks down to 3 times 3, or as far as it goes, because it's prime numbers. Everything has a number 1 factored into it. So this is made up of 3 times 3. A missing factor would be something like this. Now, how does this relate to division? Divide, yeah, let's divide both sides by 3. Because that way I'll find out what's in this one. 9 divided by 3 is 3, so 3 goes in that box. That's what the missing factor is going to be. So that's using multiplication. Let's look at if I gave you something in division. So 9 divided by 3 equals what? So how would you prove this? Right. 3 times what number gives you 9? Exactly. Because multiplication is a lot easier for kids than division. So they can work it this way. And again, since you're doing multiplication, you could do addition. 3 plus 3 is 6, plus 3 is 9, so it's 3 times. So here is the definition of division of whole numbers. For any whole numbers A and B, remember, we're defining which set these numbers belong to. Again, what are whole numbers? Zero to infinity, right? So for any whole numbers A and B, where B does not equal 0, this will be important in a second. A divided by B equals C. Okay, now, what's another way of writing this A divided by B? There are 2 other ways we can write it. A fraction or so if A divided by B equals C, or A divided by B equals C, or B goes into A, C times. So for any whole number A and B, where B says this equals C if and only if B times C equals A. Remember, since you're dealing with whole numbers, C where C is a unique. Why does the word unique have to be in there for this answer? What does unique mean? One of a kind. In other words, for A divided by B, there can only be one answer. So if you have a division, there's only one answer. And the way you test it is take the denominator times the answer equals the numerator. These have names. Does anybody know the names of these numbers? Want to take a guess? Yes, and there's a third one, divisor. So which one is which? You're right. Those are the 3 answers. Where do they go? What's this one? Yes. What's B? Good. So I make C. Very good. The quotient represents answer, same as product represents the answer of multiplication. So will it always just be that? Or is there anything else missing? There could be that, where R is called the remainder. Right. Let's see what an example of that would look like. So for example, if we had 9 divided by 4, or 4 goes into 9, it's usually easier to look at this. How many times does 4 go into 9? 2 times. 2 times 4 is 8. What do you do next? Subtract. 9 minus 8 is 1. Can 4 go into 1? No. So this is your remainder. So your answer would be 2 plus the remainder over the denominator. So it can't go any further. Let's see any examples here. Let's give another one here. Do that one. I knew there was a sheet I was going to look for y'all. It's the division rules for 1 to 12 or 13. How do you know if a number is divisible by these numbers? Yeah, there's a whole sheet I created for that. What is this method called? Very good. Very good. It's long division. Long division, I should use that Latin algebra and calculus. So it's very, very popular. How many times does 4 go into 10? So 2 times 4 is 8. Subtract them. 4 can't go into 2. So we get our quotient is 2 plus the remainder over 4. Can we go any further? Right. This can be simplified. 2 goes into 2 once, 2 goes into 4 twice. And that's the step a lot of students forget to do. Always simplify if you can go further. Which is why when you teach division, you teach them the first thing you do is simplify. Do 4 and 10 have anything in common? What is 10 made up of? 2 times 5. What is 4? They both have a 2 in common, so we're only really doing that division. So here we have our 2 plus 1/2. So you can either simplify it at the beginning or simplify it at the very end. Either way, if it's simplifiable, then you can simplify it.
If we try to teach subtraction integral fractions, or you add a zero in the equation.
What's that now again?
So, because I got taught, let's say 4/10, and once you reach the 2, I would add a decimal. And that's the
Yeah, that's when you get the third, fourth, fifth grade. Yes, then we start dealing with decimals, right? Because once this number is bigger than this number, then you put a decimal. That adds a 0 to it. For every step now, because now you're looking at this number. 2 goes into 10 5 times. Yeah, so this is 2 plus 0.5, which is 2.5. You're right. And that's something that we should be looking at is when do decimals come into play? For example, when you multiply decimals, going off script here, when you multiply decimals, actually when you add and subtract, what's the rule there? Yeah. Line up the decimals and add or subtract. So 2.45 plus 13.102. When if you look at it this way, it really means nothing. So since your addition, put the bigger number on top plus the small, line up the decimals. If you're missing a number, that's when you put a 0 in there. And then you just add all the way up, straight up and down. 2 plus 0, 2. 0 plus 5, 5. 1 plus 4, the decimal. 3 plus 2, and 1. Which is the way when you explain subtraction and addition, always make sure you teach them the rules I showed you earlier. The rule of addition is if the signs are the same, or if the signs are the same, what do? Well, if the signs are the same, take the common sign, that's your answer, and then you add the numbers, right? Right. So if the signs are the same, your answer is going to be the common sign. So they're both plus. So the answer is plus. This one, they're both minuses. If the signs are different, what do? Take the sign of the bigger number. So your answer is going to be negative. Then take the bigger number minus the smaller number. And put zeros wherever you have to. Because if you had 2.45 minus 13, that would blow the kid's mind. I said, well, I don't know how to do that. I can't take 13 from 2. So look at the signs first and then subtract them. 2 minus 0 is 2. 0 minus 5 I can't do, so I borrow 1. 10 minus 5 is 5. Again, I can't do that. So 10 minus 4 is 6. 2 minus 2 is 0, and then 1. Yeah, now you see another problem with subtraction, the borrowing, which is why you have to make sure you use those manipulatives very heavy at the beginning and make sure all the kids know what that means. Because if I had one small cube and I want to take away 5 cubes from it, I can't do that. So I got to borrow 1 from this 10. So now these, instead of this being a 10, it now goes over to being 10 ones. So these 5 and those 5 cancel, which leaves us 6. So again, that is very important. Make sure the kids understand that. So this brings us to what's called the division algorithm. The division, what is an algorithm? It's kind of instructions. If we put together a model, the instruction sheet is your algorithm. First, put these 2 pieces together, then put this piece together, then put this. It teaches you how to build the model. That's what an algorithm is. So the algorithm here says, given any whole numbers A and B, where B does not equal 0, not equal 0. The question here is this: why is B not equal 0 an important factor? No, because remember, we're dealing with A over B. You can never divide by 0. So that's where we stress the point that you can never have 0 on the bottom. So in this case, we're saying off the bat, A and B can be any whole numbers, except B cannot be 0. Okay, so if given any whole numbers A and B where B is not, there exists a unique whole number Q for the quotient and R for the remainder such that A equals BQ plus R. What I should start using then, instead of A and B, I should put N and D for numerator and denominator. So it's actually the numerator equals denominator times the quotient plus the remainder. Anybody, can you guess what the denominator used to be called instead of denominator? The top is a numerator. Denominator. What did the bottom used to be called? Trivia question. It used to be called the denumerator. If that's the numerator, that's not the numerator. That's what it used to be called. And they said that sounds stupid, so let's call it denominator. Remember, so we have here is our numerator divided by our denominator equals the quotient plus our remainder. And remember, the remainder is always divided by D. If you write it this way. But now, how do we get it to this form? If we multiply each term by D, the D's cancel here. We have DQ and the D's cancel there. So that's how that gets there. So this is how the standard algorithm looks like. But what's doing here is it's showing you that if you have a true fraction, then it should equal, the numerator should equal the denominator times the answer plus whatever the remainder is. There's one stipulation also. What's the restriction of R? What's the set? Okay, what's the domain on it then? You're right, you won't always have it, yes. So with that, what's the domain of R? So you said if there's no R, it could be equal to 0. But it has to be bigger than 0. The remainders can never be a negative number. But it has to be less than your denominator. If your remainder was larger than your denominator, that means something else can fit in there. Yeah. I know this, we've done division all our lives. We never thought all these rules would be there. That's the stuff we've been doing in our heads. You want to know another part of division that's difficult for students? Division by 1 and 0. Actually, this is actually a philosophical discussion as well. Any number divided by 1 is what? Is itself. That's the unity property. Any number divided by 1 is itself. That's good. Why? For division, you have to ask yourself, how many times can 1 go into A? In other words, if I had 3 divided by 1, how many times can 1 go into 3? 3 times. So whatever 1 goes into A times. That's the question you have to ask yourself about doing these. So if we had 0 over 1, how many times can 1 go into 0? 0. How many times can 0 go into 1? It's like saying this. How many ways can I give you nothing? Infinity. That's why we say does not exist. Because the number it doesn't exist. It's infinity. I can give you nothing forever. And I promise to do that. What's 1/1? Yeah, anything over itself is 1. How about this? This is where the philosophical question comes into play. It's either going to be 1 or 0 or infinity. It's the only thing it can be. So it can be either 1, 0, or infinity, which does not exist. What do y'all think? We have one answer already. What the rest of y'all think? Well, here we said anything over itself is 1 because 1 goes into 1 time. How many times does 0 go into 0? Remember, I could put nothing inside nothing a whole bunch of ways. So yeah, this is where it's difficult because you're violating some of the rules I just stated. Anything over itself is 1, but 0 over 0 is not 1 because there's nothing tangible there. I have nothing and I'm dividing it by nothing. How many times? So the question is, how many times can the bottom fit into the top? How many ways can nothing fit into nothing? Infinite ways. So this does not exist as well. So yeah, you see, anything over itself is 1. 0, anything with 0 on top is 0. But if the bottom is 0, that blows up a whole bunch. That question was on the mathematicians' discussion boards for centuries. So we finally figured out that it means it doesn't exist. Because it can't be 1, because how can you get a solid number from nothing? And it can't be 0 because, again, 0 is a number, is a solid number. You can get to it. So but anyway, I'm sorry. I had to throw that in there for you. But that's going to be some of the questions you may be faced by students. And you have to explain to them what that means. And that's what I say. If I have nothing, how many ways can I give you nothing? Infinity. So if I have nothing, how many nothings can I put into nothing? I can put it infinite ways. Put nothing in there, so nothing's changing. So let's see here. Oh, the exponential property of division. Exponents look like this. Number raised to a power. So if I am dividing two numbers like that, what happens here? Remember, when you multiply, you make things bigger. So do you add or subtract? With, when you multiply?
Oh,
Yeah, so if I had two numbers. So there's 3 to the 3rd times 3 squared. What would that be equal to? Yeah. Add the exponents. Since the bases are the same, I add the exponents because I'm multiplying. So this would be 3 to the 5th. How can I prove that? How do you mean?
so you do 3 times 3 times 3. And you add, or do plus 3 times 3.
Not plus, it's multiplied. So now you have 1, 2, 3, 4, 5. It's all the same number, occurs 5 times. So that's exactly how you prove it. So those 3 there, those 2 there. Since they're all multiplied, I simplify it. Instead of writing it out, because what if I had you're not going to write out 3 times 3 times 3 times 3 times 3 and count them up. Instead, you would simply add the exponents. Okay, so that's if you're multiplying, as long as the bases are the same, you add the exponents. That's multiplying because you're making it bigger. Division is just the opposite. What do you think you do there? You subtract the exponents. Why is that the case? It's an easy way to put this. Using this rule, we know that I can rewrite 1 over a to the power n as a to the power negative n. That's what a negative exponent means. A negative exponent means that this number actually switches side of the dividing line. How would I prove that? If I had 3 squared, that's 3 times 3. On the bottom, I have 5 3s. When you divide, you cancel. The number on top, since everything's gone, is a 1. And I have 3 3s on the bottom. True so far? But now what if I use this rule with these numbers? This is n and this is m. I would have 2 minus 5. What is 2 minus 5? Negative 3. I'm sorry, it should be 3. That should be 3. It's the base 3. So this shows us that the negative exponent simply means flip it across the dividing line and change the negative sign. And it also shows us that division is the same thing as subtraction when it comes to exponents. Because we're canceling things. So far, so good. I'm going to spend a day also just going through all the exponential rules because you'll eventually be faced with that. And I'll explain all the rules. We already know anything to the first power is itself, because the exponent simply tells me how many times it occurs. And we also know, I hope, 3 to the 0 power is one. Why is it 1? Now that I taught you this, I can now prove this. Here's your first proof in mathematics. Let's prove that this is true. Let's start from the back. What equals 1 in mathematics? Always equals 1, besides 1 itself. Is there an equation we can create that always gives us 1? Anything over itself, what does that equal? That always equals 1. Anything, I can make it as big as I want to. They have to be the same. Using the rule I just told you, what do we do with the exponents? We subtract them. What is n minus n? 0. So that's why it is what it is. So this is, again, I want to spend a day, one day, just going through nothing but the exponents so we can have a better understanding what those really mean. How would you do that using base 10 blocks?
So running it up to 50, or no, do I have to do something to the bottom?
Running it wouldn't work. Think of one of the 3 methods we talked about. How would you represent 49 in blocks? That's 4 times 10 plus 9 times 1, right? So those are the 4 tens. And there's the 9 ones. We can use either the subtraction method or the set partition method. So we have 49 minus 7. So we would take these and take away 7 blocks each time. So we took away 2, 4, 6, 7. That leaves us with 42. Take away 7 again. So 1, 2. Now we have to break this one down. That's 1, 2, 3, 4, 5, 6, 7. That leaves us with 35. Do it again. 1, 2, 3, 4, 5. We got to borrow another one of these. So we had 5 here, 6, 7. That leaves us with 20, 28. Two, 4, 6, 7. That leaves us with 21. So we gotta take another one of these. We have 1, 2, 3, 4, 5, 6, 7, which leaves us with 14. Take away 7 more. We need to borrow that one. So we have 2, 4, 6, 7, which leaves us with 7. And the last 7 gives 0. So we have 1, 2, 3, 5, 6, 7. That's one way we do it by using the subtraction method, using blocks. So that's also the same way we use the set method. We would break down these blocks until we had 7 in each set. 1, 2, 3, 4, 5, 6, 7. Which is in essence what we're really doing over here. So we'd get 7 blocks, put them in there, break them down even further, and we keep on doing that until we run out of blocks. Yeah, so next look at base 5s. That's gonna take some time. Because it's much more difficult of doing base 5s or base 2s or base 3s because we can't just do it 12 goes into, let's say it's, you can't do 46. Can do 36. We do 24. So what does this number really represent in base 10? What does 4, 3 base 5 represent? Remember what these numbers represent. The first one represent the ones column. Yeah, so that's 1. The other one is the 5s column. So 5 times 4 is 20. That's 20. This number here is actually 23 base 10. And what does 1, 2 base 5 represent? So we have 1 of those and 2 of those. 1 times 2 is 2. 5 times 1 is 5. That number represents 7 base 10. Actually, let's make this one a 1. I'll show you how. because we have a shorter time. So it's going to be 21 over 7. What is 21 over 7? 3 base 10. So how would we represent 3 in base 5? Because it's in the ones column. It's not bigger than 5. Again, that we'll do next time, because when we think about changing bases, especially when it comes to multiplication, especially when it comes to division, because even in computers, division is a whole different process. Okay, yeah, we'll finish up this, but this finishes up the chapter pretty much. So try to finish up chapter 3. We'll do some more next week on this, and then we'll start chapter 4 and see how far we get there. Okay, everybody, have a great, safe vacation while you're away. And I'll see you guys next week.